So very good morning to everyone. I hope so everyone are preparing well. So welcome to the revision class. So today what I will be discussing is that I will be just giving you the important formulae which are important and other things. So if you are having any conceptual doubt, you can ask. Okay. First thing, we shall start with chapter 1. So in chapter 1, the most important thing is first one is your hydrograph. So what is hydrograph? Basically, hydrograph is a plot between intensity of rainfall versus time. Second thing is mass curve. So mass curve is a plot between cumulative depth of rainfall versus time. Hydrograph, area of hydrograph represents so area of hydrograph will give you depth of rainfall. Third point, so intensity of rainfall. Intensity of rainfall is equal to, so intensity of rainfall I is equal to P by T. So these are some basic things which we have to remember here. Then fourth thing, you may get a problem based on optimum number of rain gauges. So more or less it will be like a summary of complete subject here. So conceptually, if you are having a doubt, you can ask me later also. Okay. So in optimum number of rain gauges, we represent it by N. So formulas which are required will be PA, average rainfall is equal to P1 plus P2 till PM divided by M. So where M is representing your number of existing rain gauges. Second one, so you require a standard deviation formula, which is nothing but summation of Pi minus Pa whole square whole divided by M minus 1. So third one, so you require a CV formula, CV equal to sigma divided by Pa into 100. Fourth formula, so it is nothing but your N formula, N is equal to CV divided by E whole square. Now here what you have to remember is that two additional points. So from exam point of view, for you this will be important and this will be important. Complete lengthy question he cannot ask you. So these two, third and fourth formula, if you remember, that will be more useful. So fifth point is that if you want to find out additional number of rain gauges, then you should find out n minus m. So sixth thing, percentage accuracy is equal to 100 minus percentage error. Now, fifth point will be important. Sixth point will not be important at all. So third one, fourth one, and fifth one are important from exam point of view. Next concept which is important here is estimation of missing rainfall data. So in this first one, normal ratio method. So normal ratio method, Px divided by Nx is equal to 1 divided by M into bracket P1 by N1 plus P2 by N2 plus till Pm divided by Nm. So where N values are representing normal annual average precipitations, P is annual rainfall values, M represents here number of working stations. So second one, you require a simple arithmetic average procedure. So you have to check the 10% condition. I hope so you remember how to check the 10% condition. Increase the Nx value by 10%, decrease the Nx value by 10%. If all remaining N values are within this obtained range, then you have to go for simple arithmetic average procedure. So simple arithmetic average procedure is PA is equal to P1 plus P2 till Pm divided by M. Now, last theoretical point what you have to remember in this chapter, which is important, is double mass curve. So, what is a double mass curve? It is a plot between cumulative annual rainfall at station X versus cumulative annual mean rainfall of base stations or group stations. So last point what you have to remember is double mass curve is used to check the consistency of a rainfall record. So these are the things which you require for chapter number 1. So anyone is having any doubts, you can raise your hand. Hello.
Sir, what if sum of the n values is exactly equal to 10?
That condition will not come by generally.
Okay, sir. Okay, sir.
Okay. So these are the things which you require from chapter number 1. So if there are any doubts with respect to thing, you can ask. Check for consistency or inconsistency of a rainfall record. Anything you can say. Better to say, write it as always. Check for inconsistency of a rainfall record. If it is consistent, then not required for us. So this PDF immediately I will be uploading. So these are the things which you require from chapter number 1. So chapter number 2. Mean precipitation calculation. So here dividing area you have to remember. I hope you remember dividing area. But still once I will tell you how to divide the area again. So first one is arithmetic mean method. So PA will be equal to P1 plus P2 till PM divided by M, where M is representing number of rain gauges within the catchment. So M represents number of rain gauges within the catchment. So second thing which you require is Thiessen polygon method. So Thiessen polygon method, let me take a diagram and show you how to divide. So assume that this is a catchment area, which is in the form of a square, plus above that there is an equilateral triangle. There are 5 stations, let me take 1, 2, 3, 4 and 5. Now first always you have to start joining with the nearest station. So which is the nearest station here? The nearest station will be 5, 2. So join 5, 2. Now you can't join 1, 4. You cannot join 1, 3. Why? Because the rule is that 2 straight lines should not cross each other. Straight line is nothing but a line joining 2 stations. So this line should not cross each other. Now if you want, you can join 5, 3 or 4, 2. So let me join 4, 2. So joining is over. Now you have to draw perpendicular bisectors. So perpendicular bisectors to all straight lines joining stations you have to draw. Okay. Now this is also perpendicular bisector. This is also perpendicular bisector. After drawing perpendicular bisector, you have to extend them. Now remember that you have to extend till required thing. So till they meet any line, you have to extend. Now as you start extending with respect to equilateral triangle, so all three will meet at a single point. Now perpendicular bisector for phi 2, you can extend in the downward direction till here. Okay. So for phi 4, you can extend. 4 3 bisector, you can extend. 2 3 bisector, you can extend. But bisector for 4 2, bisector for 4 2, you cannot extend. Why? Because when extended, it will pass through station. Now, if I take rainfalls at one station P1, rainfall at station 2 is P2, P3, P4, and P5 are the rainfalls at respective stations. Now you can assign the area. Area is with respect to perpendicular bisector. So this will be the area for station 1. Now for station 2, this will be the area. This is area for station 2. This is area for station 5. Then area for station 3. This will be the area for station 3. So this is area for station 3. This is area for station 4. Now you can find out average rainfall. So average rainfall PA will be equal to P1 A1 plus P2 A2. So continue till P5 A5. Total 5 areas are there, 5 rainfall values divided by area 1 plus area 2 till area 5. This will be equal to, in general, you can write summation of P into A divided by summation of A. Or if you want to write with respect to Thiessen weights, you can write like this: P1 W1 plus P2 W2 plus continue the values till PM WM. Or in short, you can write summation of P into W's. So W1 is that these W1, W2 are Thiessen weights. You can write A1, W1 is equal to A1 divided by summation of A. W2 is equal to A2 divided by summation of A, and so on. Next thing. So sum of Thiessen weights. So sum of Thiessen weights will be equal to 1. So these are the points that you have to remember with respect to this Thiessen polygon method. Now next, third method. Third method is which method? Third method is your isoheital method. So if area is with respect to 2 isoheids, you have to take the average. If area is with respect to only one isoheid, then you should take it directly. So assume that first area is with respect to only one isoid, so directly P1 into A1. So next area is with respect to 2 isoids. Let me take P1 plus P2 by 2 into area 2 plus P2 plus P3 divided by 2 into area 3 plus continue. Whole divided by total area A1 plus A2 plus continue. So this is your isoheital method. So what is an isoheight? Isoheight is the line joining the points having a equal depth of rainfall. So this is about your second chapter, that is nothing but mean precipitation calculation. So these points you remember, that is more than sufficient. So isoheight is a line joining the points having equal depth of rainfall. Next, chapter 3. Frequency of point rainfall. And probability. So frequency of point rainfall and probability. Now here, so you are supposed to remember some formula. Small p is equal to 1 by t, where t is the return period. Second one, small q is equal to 1 minus p. Third one, PR comma n is equal to NCR into p to the power r into q to the power n minus r. Fourth formula, P0 comma n is equal to q to the power n. Fifth formula, P1, that is nothing but risk factor, is equal to 1 minus q to the power n. So these are the things which you have to remember. These four are more than sufficient. Suppose if you want to remember a return period formula, sixth one. So Weebull's formula, T is equal to n plus 1 divided by m. California formula, T is equal to n divided by m. Hessen's formula, T is equal to n divided by m minus 0.5. So these are the formula part which you are supposed to remember from chapter number 3. Now chapter 4, chapter 5, chapter 7 will be most important. Most of the times you may get question from those chapters itself, and even chapter 10. So let us see what are the important things in chapter 4. So chapter 4 is evaporation and transpiration. So first point you have to remember, formula EP is equal to P plus or minus Z. So where EP is representing pan evaporation, P rainfall depth, Z depth of water removed or added. Now, if water is removed, you have to take it as a negative. Water added, you have to take it as a positive. Second important point which you have to remember is that, so pan evaporation over. Now lake evaporation. Lake or reservoir evaporation. E is equal to Cp into Ep. This is one important equation that you have to remember. Now Cp is nothing but pan coefficient. So Cp is pan coefficient. So for US WB class A pan, you have to take a value of 0.7. So for IS modified class A pan, you have to take a value of 0.8. For Colorado sunken pan, 0.78, and for US GS floating pan, you have to take it as 0.8. So this is the second thing. Third point, volume of water evaporated from lake or reservoir VE, let me say. So this is the third equation that is important, you have to remember. So volume of water evaporated is equal to area into Cp into Ep, where A is representing your average surface area, Cp is pan coefficient, Ep is your pan evaporation. Fourth point, you have to remember equation for water budget method. So water budget method, simple equation you have to remember. Summation of inflows minus summation of outflows is equal to change in storage plus or minus delta S. If you want to elaborate, you can elaborate like this. So rainfall is positive plus surface inflow minus evaporation minus seepage loss minus you can take abstraction. This is equal to plus or minus delta S. So condition A is that if summation of inflows is greater than the summation of outflows, then you have to use positive delta S. Water level rises. Condition B is that if summation of inflow is less than summation of outflows, then you have to take a negative delta S. Why? Because water level will decrease. Next point, fifth point. So energy balance method is not so important. So chemicals used for to reduce evaporation. Cetyl alcohol and sterile alcohol. Seventh one. So evaporation is measured using evaporimeters or atmometers. Then your transpiration is measured using phytometer. Then evapotranspiration is measured using lysimeter. Rainfall is measured using rain gauges or ombrometer. Or you can call pluviometer. Humidity is measured using hygrometer. Then wind velocity anemometer. So these are the points with respect to which you have to remember from evaporation and transpiration. So one more equation is there. Generally till date it is not asked, but there is a good chance that you can get a question from that one. So eighth point, you can go for Banach-Riddle equation. I hope so you remember. Evapotranspiration is equal to 2.54 kph into Tf divided by 100. So ET is evapotranspiration. In a centimeter. K is crop coefficient. Or you can say consumptive use coefficient. pH is a percentage sunshine hours. Tf is monthly mean temperature in Fahrenheit. So conversion formula for temperature to convert from degree centigrade to Fahrenheit, 1.8 T degree centigrade plus 32. So this formula also you remember. So these are the equations and points which we require from chapter number 4, evaporation and transpiration. So next chapter, very important chapter. Chapter 5, infiltration. So in infiltration, only two things are very, very important. First thing is your Horton's equation. So Horton's equation is what? F of t is equal to Fc plus F naught minus Fc e to the power minus kT. Here, F of t is representing infiltration rate at any time t. F naught is initial infiltration rate. Fc is constant or steady state or final or ultimate infiltration rate. Okay. Now, generally all these three things will be either in centimeter per hour or mm per hour. K is representing what? Horton's constant. K is representing Horton's constant. Horton's constant units will be K per hour. Now, I'll show you the graphical thing also. So y-axis is infiltration rate either in centimeter per hour or mm per hour. X-axis is time in terms of hour. So at the end, I'll give you time. So if you want to ask anything, doubts, conceptual thing, you can ask anything. And also I'll try to help you out with some tips for the examination. Okay. This is your Horton's curve. So this is F naught. This is Fc. This is Tc I have taken. This is time t is equal to 0. Now for this curve, equation will be f of t is equal to Fc plus F naught minus Fc e to the power minus kT. Now one more thing that we have proved, what is that? This shaded area is nothing but capital Fc, which is equal to F naught minus Fc divided by K. Now this is your graphical thing and this is your equation which you require. Now let me go for the further points with respect to this one. So in this you have to remember n number of things. First one, if you want to find out total infiltration depth, capital F, then you have to integrate your equation f of t with respect to dt, substitute the limits from 0 to t in general. Second thing, suppose this is the condition. So this is in a general. Okay. Now suppose if I'm asking you to find out infiltration depth till time t, it means that you have to find out area till here. So for that you should find out this complete area. So to find out this complete area, simple thing. So infiltration depth F is equal to integrate your equation F of t with respect to dt and substitute the limits from 0 to t. So this point you have to remember, it is very important. Third point. Suppose if I am asking you to find out infiltration depth from T1 to T2, then you are supposed to find out area between these two things. So time interval you have to take properly. Now capital F is equal to infiltration depth F is equal to integrate your equation F of t with respect to dt, substitute the limits from T1 to T2. This is more than sufficient. Now, most important thing you have to remember is that time t should be in hours. So sometimes it will be given in terms of minutes. Some students in a hurry, they will mention directly in terms of minutes itself. So you are not supposed to substitute in terms of minutes. You are supposed to substitute in terms of hours. This thing you remember, it is very, very important. That is the mistake generally students do. Fourth point, shortcut. So shortcut to find out infiltration depth. Applicable when a given time t is greater than or equal to tc. So shortcut is applicable when given a time t is greater than or equal to tc, that is steady state attained. So what is that shortcut? Capital F is equal to Fc into T plus F naught minus Fc divided by K. This is your shortcut method to find out the infiltration depth, which is only applicable when a given a time t is greater than or equal to Tc. So these are the 4 points which are important with respect to Horton's curve. So one more point. Okay. So one more point in Horton's curve, fifth last point. Suppose hydrograph data is given. So intensity versus time. So hydrograph is given. With intensities I1, I2, I3. We can find out rainfall depth P is equal to I1 into T1 minus T0 plus I2 into T2 minus T1 plus I3 into T3 minus T2. And Horton's curve is given. So Horton's curve equation is given, or with respect to the direct diagram is given. So if Horton's curve is given and it is in this format. This is your F naught value. This is your Horton's curve. Let me draw it properly. So if this is your Horton's curve. Now you have to find out infiltration depth F. So for that, infiltration depth F will be equal to, so this is your infiltration with respect to the first hour. So what you have to write here? I1 into T1 minus T0 plus, next you should find out this shaded area. So to find out that, you have to integrate the equation f of t with respect to dt, substitute the limits from t1 to t3. So this will be your f of t equation for Horton's curve. So finally, area above this is nothing but runoff. So runoff R will be equal to P minus F. So these are all important points with respect to your Horton's curve. So I have shown you in some problems. So T is greater than or equal to Tc, that you can check by substituting. When you substitute time T is equal to given time T, when if your f of T is equal to Fc directly, then you can say that steady state is attained. So these are your 5 points with respect to your Horton's curve. Next important thing in this chapter is infiltration indices. So in that first one is your phi index. This is the only important thing for you. So phi index is equal to PE minus R divided by TE. So here PE is representing rainfall depth. Corresponding to time TE. Capital R is representing runoff depth. TE is the time of excess. So time of excess. So 3 conditions you have to remember. I hope so you remember them. If intensity of rainfall is greater than 5, then there will be runoff. If intensity is equal to 5, then there will be no runoff. If intensity of rainfall is greater than 5, less than 5, then also there will be no runoff. These 3 conditions you have to remember, and I hope so you remember the trial and error procedure. So these are the points which you require from chapter number 5. So if there are any doubts, conceptual doubts, you can raise your hand, we shall discuss, and then we shall move further to the next important topic, hydrograph. So any doubts are there, you can raise your hand. Okay, let us continue. So next topic, is, give me a moment, 1 minute, I'll be back. Or we shall take a small break of 10 minutes. $10 break we shall take, then we shall start exactly by 8:10 we shall start again. So if anyone is having any doubt, you can raise your hand or you can drop a message. I'll watch it. Okay. Again, we shall start by 8:10 a.m.